Welcome to Module 2 Algebra. This topic makes up 13 to 15 questions of the SAT Math section. So it is one of the larger topics on the Math section of the exam, which makes sense because algebra is the foundation of all higher math. In this module, you'll be working on 8 different lessons. In each lesson, you'll go through 3 different levels. Level 1 is the beginner level. This is the introduction to the topic where you'll learn the foundational skills. Level 2 is the intermediate level where we'll build off of those foundational skills that you learned about in level 1. And level 3 is the expert level where we'll work on the most complex problems that involve critical thinking and problem solving. In this video, we'll be working on Lesson 1, Solving Linear Equations and Inequalities. At this point, please make sure that you have your workbook printed out so you can follow along with me as I assign problems to you. If you don't have your workbook printed out at this time, please pause this video and print it out now. So what is an equation? Well, chances are, if you're at this point where you are taking the SAT, you probably know what an equation is. But just in case, I will go over the basics. An equation is a mathematical statement that contains an equal sign, not to be confused with an expression, which is a mathematical statement that does not contain an equal sign or any type of equality or inequality symbol. So if you see here, I have this example, 9x minus 5 equals 16, and I've labeled each part of the equation for you. So we have our coefficient, which is the number next to the variable. We have our variable, which in this case is x. We have our constants, which are your numbers that don't contain a variable. Those are numbers that are not attached to a variable. And we have our equal sign, which is what makes this statement an equation. So how do we solve equations? We solve equations by using inverse operations. Inverse operations are operations that undo each other. So the goal is, when solving an equation, to isolate the variable to find its value. And in order to isolate the variable, we have to undo everything that's being done to it. So let's solve this equation together. 9x minus 5 equals 16. Let's start by removing this minus 5. So the inverse operation of minus 5 is plus 5. So we're going to add 5 to both sides, right? Because it's an equation, both sides of the equal sign are balanced. They're the same. So if we do something to one side, we have to do the same exact thing to the other side of the equal sign to keep both sides balanced. So minus 5 and plus 5 will cancel out because they combine to 0. We'll bring down our 9x and we'll add 5 to 16 and we get 9x equals 21. Now we still have to get rid of this 9, our coefficient. X is being multiplied by 9. So the inverse operation of multiplying by 9 is dividing by 9. So we divide both sides by 9. Our 9's cancel out. And we get our solution, which is x equals 7 over 3. What is an inequality? Well, an inequality is a mathematical statement that contains an inequality sign, right? Our inequality signs are less than, greater than, less than or equal to, greater than or equal to, and not equal to. So we have this inequality here, 9x minus 2 is greater than 16, and I've labeled all the parts of the inequality for you, right? We have our coefficient, our variable, our constants, and in this case, an inequality sign, and we're working with greater than. How do we solve inequalities? Well, very similar to solving equations, we use inverse operations to solve inequalities. The difference will come at the end once we get to the solution. So 9x minus 2 is greater than 16. Let's first get rid of our constant. Let's get rid of this minus 2 right here. The inverse operation of minus 2 is plus 2. So we'll add 2 to both sides of the inequality symbol. Minus 2 and plus 2 cancel out because they combine to 0. We bring down 9x is greater than 18. Once again, we have to divide both sides by 9 in order to get rid of this coefficient. Our 9's cancel out, and we get x is greater than 2. So in this case, for an inequality, we don't just have a solution. We call x is greater than 2 the solution set. It's a set of solutions, right? When we had an equation and we get a solution, our variable was equal to one value. But in this case, x is all the values greater than 2. It's every value greater than 2. It's not just one value. It's everything greater than 2. So some values in our solution set would be 3, 4, 5, 10, 105, 215.7. Anything and everything that's greater than 2 is part of our solution set. Please pause this video now and work on the lesson 1, level 1 problems in the workbook. Moving on to level 2, our intermediate level. I have 4 examples for you here. I want you to pause this video and think which one doesn't belong and why. So you may have realized that each option doesn't belong for its own reason, right? Number 1, it's the only equation that uses y as a variable instead of x. It's also the only equation that can be solved in one step. Number 2 is the only equation that uses the distributive property. Number 3 is the only equation that has variables on both sides. And number 4 is the only equation that has a fraction. We're going to go through several of these options together just to discover how we can solve equations in different cases. Let's look at the first one. This is an example of an equation that uses the distributive property. Now, I'm going to tell you how to read this properly, how to read it like a mathematician. Many people might read this as 9 equals 3 times x plus 7. But that is actually incorrect. That's the incorrect way of reading this. The proper way of reading this would be 9 equals 3 times the sum of x and 7. If you say it like that, then I understand that the sum of x and 7 is in parentheses. If you don't specify that it's 3 times the sum of x and 7, I might not understand what you mean. I might think you mean 3x plus 7. So again, we read this as 9 equals 3 times the sum of x and 7. So our equation looks a little different here, but the goal is still the same. We want to isolate our variable x. So since we're using the distributive property, we have 3 on the outside of the parentheses, right? The sum of x and 7 is being multiplied by 3. So let's get rid of that first by using inverse operations and dividing both sides by 3. The 3's will cancel out. 9 divided by 3 is 3. So we bring down 3 equals the sum of x and 7. And now all we have to do is get rid of the plus 7 by subtracting 7 on both sides. And we plus 7 and minus 7 cancel out because they combine to 0. And we get our solution, which is negative 4 equals x, or x equals negative 4. Next example is solving equations with fractions, everybody's favorite, right? Goal is still the same, isolate our variable x. So we're going to start by adding 8 to both sides. Minus 8 and plus 8 cancel out. We bring down 1/4 x equals 20. So now we have to divide both sides by 1/4. So this is where you have to think back to middle school when you learned about dividing fractions. Now, technically, you will have a graphing calculator on the SAT, whether you're using the one on the digital platform or your school is providing you with a graphing calculator. There are fraction functions on the graphing calculator. So technically, you can just put into the calculator 20 divided by 1/4, and you'll get your solution. But when we divide by fractions, if you want to do it algebraically, if you don't want to use the calculator, dividing by 1/4 is the same thing as multiplying by 4, right? When we divide fractions, you're multiplying by the reciprocal. What is the reciprocal, right? We have to think back to middle school. The reciprocal is your fraction flipped. So the reciprocal of 1/4 is 4/1, which is just 4. So we multiply both sides by the reciprocal. So in this case, we're multiplying both sides by 4/1, which is just multiplying by 4. 4 and 1/4 cancel out. And we get our solution, which is x equals 80. Now solving with negatives and variables on both sides of the equal sign. So we have this equation here, 10 minus 4x equals negative 9x. Notice how we have x on both sides of the equal sign. That makes it difficult for us to solve. So whenever this is the case, the first thing you should always do is collect your variables on one side of the equal sign. So what I'm going to do is I'm going to take the minus 4x, we'll use our inverse operations and add 4x to both sides. Minus 4x and plus 4x cancel out, and we bring down 10 equals negative 5x. Now we only have x on one side of the equal sign, and we have one step left to solve. We'll divide both sides by negative 5. Our negative 5's cancel out, and we get our solution, which is x equals negative 2. Now let's take a look at an inequality. 10 minus 4x is less than or equal to negative 9x. Very similar to the equation that we just solved. Again, we have variables on both sides of the inequality symbol, so we'll collect the variables on one side by adding 4x to both sides. Minus 4x and plus 4x cancel out, and we get 10 is less than or equal to negative 5x. Same thing, inverse operations, we divide both sides by negative 5. Negative 5's cancel out. And now we're left with negative 2 is greater than or equal to x. What do you notice happened here in this final step? Well, I notice that less than or equal to changed to greater than or equal to. Why is that the case? So when we're working with inequalities, there's a rule. Anytime you multiply or divide both sides of the inequality symbol by a negative number, you must flip the symbol, right? So only when we're multiplying or dividing by a negative number, you must flip the symbol, right? This is a very, very important rule to remember because it's such a simple mistake that you could make by forgetting to flip the symbol that will cost you the points on the exam. So please Once again, anytime you multiply or divide both sides of the inequality symbol by a negative number, please flip your inequality symbol. Please pause this video and work on the lesson 1 level 2 problems in the workbook. Moving on to level 3, our expert level. Turn to page 5 in the workbook and work on questions 9 and 10. I want you to solve both of these equations for the variable and ask yourself, what do you notice and what do you wonder? So let's take a look at the first one. We have 3 times the sum of 5x and 2 equals 15x. Let's solve for x by first getting rid of this 3 and dividing both sides by 3. Our 3's cancel out. We bring down 5x plus 2 equals 5x. Now we have variables on both sides of the equal sign, so we're going to try to collect them on just one side. So let's subtract 5x on both sides. Now this time, something interesting happens. 5x and minus 5x cancels out over here and over here as well. And we're left with this statement here, 2 equals 0. What do you notice about the statement 2 equals 0? Well, I notice 2 is not equal to 0, right? This statement here is not true. So anytime you solve an equation and you get to the end and you end up with a mathematical statement that is not true, that means that the equation has no solution, right? So we solve this equation, we ended up with a statement that says 2 is equal to 0. That's a false statement, so that means there is no solution to this equation. What about the next one? Negative 2 times the sum of 4y and 1 is equal to negative 8y minus 2. Let's do the same thing. Solve for y by inverse operations. We'll divide both sides by negative 2. On the left-hand side, negative 2 cancels out. We bring down 4y plus 1. And on the right-hand side, we divide negative 8y by negative 2 and get 4y. And we divide negative 2 by negative 2 and we get 1. So I already notice at this point, both sides of the equal sign are exactly the same. I'm already noticing that. If you notice this at this point, you can stop the solving process now. But if what you're noticing is that we have variables on both sides of the equal sign, we can continue to solve. So we can continue to solve by collecting our variables on one side and subtracting 4y on both sides. Both of those cancel out, and we're left with this statement, 1 equals 1. Now we have a statement that's always true. Both sides of the equal sign have the same exact value. 1 is equal to 1. And when we solve an equation and we get something that looks like this, it means that there are infinite solutions to this equation. So I just want to backtrack a little bit. When you get to this point right here, 4y plus 1 equals 4y plus 1, and you notice both sides of the equal sign are exactly the same, you can stop right there and you can already say this equation has infinite solutions. But you can continue to solve all the way to the end to get 1 equals 1. It doesn't matter. It all depends on what you notice as you're solving. Please pause this video and work on lesson 1, level 3 in the workbook. After you finish your problems in the workbook, you can stop this video and move on to the video for lesson 2.